Okay, guys, this is our last lecture for CE688. Okay, so we talk about the final review, the topics we're going to cover for the final exam. All right, so first of all, the time, May 11th, which is Tuesday next week. Okay, so from 2:15 to 4:15 p.m. Okay, so same location online. I will upload the final exam to Laulima, so you can input the answer to Word and send me a copy. Okay. So it will be open book, green calculators. We have around 20 to 25 questions, including true and false, multiple choices, short answers, and calculation questions. Okay, so same as the two midterms. Okay, so this is the list of topics we will cover for the for the final exam. Okay. First of all, raw materials used in manufacturing of cement. Okay. So remember the oxide we need: lime, iron, silica, and alumina. Okay. Olisa. You should also know the difference between constituent materials and the compounds. Okay, so constituent materials means the different type of oxide, okay, such as calcium oxide. Okay, and the shorthand for calcium oxide is C. Silicon oxide shorthand is S. Okay, alumina and ferrite A and F. Okay, for compound we have C3S, C2S, C3A, and C4AF. Okay, so these are compound. Okay. Then it is important to know the hydration process, okay, of C3S, the basic 5 stage of hydration, okay, from the rapid heat evolution to dormant period, to accelerating, to decelerating, and steady state. Okay. So that's the 5 stage of hydration. And why we have the 5 stage? For example, why during the dormant period there's not too much heat generated? Okay. And different roles of cement component in hydration and strength development. Okay, so how the reaction of C3A, C2S, and C3S different from each other. Okay, and what are the hydration products for these compounds? Okay, and what's the difference? Morphology means the shape, size, density of these major hydration products. Okay, and also the strength. Okay, remember the strongest hydration product is always CSH. Okay. And different type of voids and air voids in concrete, and their difference. Okay, from the smallest is geopores, which is in nanometer level. Capillary pores is in micrometer level, and we have large and small and medium capillary pores. Okay. We also have entrained air and entrapped air. Okay. So you should know this different type of air and voids. Okay. And the role of gypsum. The major role of gypsum is to react with C3A, because without gypsum, C3A will directly react with water and generate a lot of heat very fast. Okay, so slow down reaction of C3A and reduce the setting time. That's the major role for gypsum. There are some minor roles for gypsum, including reduce the shrinkage, but the major role is to reduce the reaction speed of C3A. And then different type of cement, including the difference in chemical and physical property of cement and their applications. Okay, for example, type 3 cement So this is a fast setting cement where we want higher strength, or we want a winter construction to make sure the concrete will not freeze. So we use type 3 cement. Next, major chemical constituent of chemical admixtures, mineral admixtures, including flash, silica fume, and slag. Okay, so we have a table to summarize the property of this, and also physical properties of cement powders plus these mineral admixtures. Okay, so we have another table summarize the properties of these materials. Okay, and how pozzolanic materials, also called mineral admixtures, affect fresh properties and hardened property of concrete. Okay. For example, how flash can affect the setting time and early age and final age strengths of concrete, and why that's the case. Okay. And then chemical admixtures. So we discussed air entraining agent, superplasticizer, accelerator retarder, and so on. Okay, not too much on corrosion inhibitors. You should know why and how these admixtures can work as they're supposed to. Yeah, so that is chemical admixtures. Then about curing, how moisture and curing temperature affect the strength, gaining speed, and also the final strength. So basically, the longer moisture curing, we have a better strength and lower permeability. So that's all good. For curing temperature, lower curing temperature, you will have a higher final strength, but lower early age strength. Higher curing temperature, you will have a higher early age strength, but lower final strength. And you should know why that's the case. Okay. And then fresh properties, workability, consistency. Okay. How we can test the consistency. So we use slump. For normal concrete, we use VP test for stiff concrete. And for SCC, we can use slump cone. And then air content tests. We have a test based on volume, and the other one is based on pressure. Okay. And limitation on the pressure type of air content test. Okay, so you can only use for normal concrete with aggregate, with no porous aggregate. Okay, so otherwise it will overestimate the air content using the pressure type of air content tests. Another fresh property about segregation and bleeding. What are segregation, and bleeding, and how we can control these problems. Then the idea of strengths, modulus of elasticity, and porosity. Okay, so higher porosity, you will reduce the strength and also reduce the modulus of elasticity of concrete. And the next one, aggregate, cement paste, and ITG. So these are the three major components in concrete. And the strength of the concrete depending on the weakest of these three. Okay. So for normal concrete, the weakest part will be ITZ or the paste. Okay. For high strength concrete, the weakest link may be the aggregate. All right. Next, influence of specimen size and geometry on mechanical testing. Okay, how the length to diameter ratio, the size of the specimen will affect the apparent strength of concrete. Okay. And what is the end effect? Basically means the friction provided by the top and bottom of the compressive strength machine Okay, how that will affect the strength of concrete. And then the next is about aggregate, how to calculate the finest modulus of the sand. What are the four major moisture conditions of aggregate? What is absorption capacity, total moisture, and moisture content? Okay. And most importantly, how to adjust moisture content for the mix design. Okay, so that is very important. Okay. So you should know the basic procedure for mix design. The table will be given if there's a question about mix design. Okay. And then elastic properties, viscous properties, and viscoelastic properties. So you should know for concrete, it has both viscous and elastic component. So the strain versus time response of viscoelastic materials such as concrete will be time dependent. And then paste versus mortar versus concrete. So basically, when we have aggregate, we will have more component. Aggregate paste plus ITZ. Then where the crack will first generated will control the pattern of the crack, the fracture, and also the final strength of the materials. And then localization concept and post-peak behavior. So that's the fracture behavior of concrete. Okay. So also depending on the weakest link. Okay. For localization concept, it talks about when concrete generated cracks here and there, then cracks in certain location will opens up. Okay. And that caused the final failure of concrete. In other part of the concrete, it can still resist some of the stress. And that's the reason we have a post-peak behavior for concrete. And this is very important for steel reinforced concrete. Okay. Right. So that is about mechanical properties. And then durabilities. So what affect durability of concrete the most? So that is definitely permeability of concrete. Okay, or how easy air and water can penetrate the concrete. Okay, so permeability is the most important. And then you should understand freeze-thaw damage, corrosion, alkali-silicate reaction, and software attack. Okay, so mechanism, chemical reaction equation, if there's any, what are the influencing factors, and how we can control these physical or chemical attacks. Okay. So this is also a very important part. Okay. Permeability and durability, again, number one factor is permeability. Okay. And how we can reduce permeability of concrete. Okay, so we have many different methods. Okay. For example, we use lower water cement ratio concrete. We use pozzolanic materials. Okay, we use silica fume. We can use fibers to control the crack size after concrete crack. So that may also help to reduce the permeability. Okay. All right. So the next is about shrinkage and creep. All right. So we discuss different type of shrinkage, from chemical shrinkage, which is caused by hydration, the chemical reaction between cement and water. Okay. And also dry shrinkage, drying of the concrete when the water lost to the air, or autogeneous shrinkage, when the water is dried out due to self-desiccation, that only occurs in concrete with low water cement ratio. Okay. Okay. And Kelvin Laplace equation. So that's the equation controlling the dry shrinkage and also autogeneous shrinkage. Okay, so it tells us when we reduce the size of the pores, reduce the internal RH inside the pores, okay, we can increase the shrinkage stress, okay, and also the surface tension of the pore solution. So that's the reason why shrinkage reducing admixtures works by reducing the surface tension of water inside the pores. Okay, so you should understand that. Okay, 5 stage of dry shrinkage. So let's talk about water loss from different location, okay, depending on the size of the pores. So the water loss from the smaller pores, based on the Kelvin Laplace equation, the shrinkage stress will be higher. So we have more shrinkage for the same reduction in RH. Okay. Then next, influencing factors and control method for shrinkage. Okay. All right. So you can control water cement ratio, moisture loss for dry shrinkage. You can control the volume of algae if you can do that. Humidity, all the factors affecting shrinkage. Okay. Other potential measure, you can control the shrinkage. Okay. Next, creep and relaxation. Okay. And recovery of the creep deformation. Okay. So creep is similar to shrinkage of concrete. Okay. And part of the creep is recoverable, and part of creep is permanent. Okay. So what is difference between? So next topic is the difference between high performance concrete and high strength concrete. So again, high performance concrete, high strength concrete is not equal to high performance concrete. So strength just means the strength is higher, but high strength cannot guarantee other performance is also good, okay, such as durability. Okay. We also talk about different type of high performance concrete, including SEC. Okay. What's the difference between SEC and conventional concrete, and how we can check the flow, the passing, and the segregation of SEC. Okay, so that's easy because it's open book. If it's a closed book, it's much harder. It's open book. Fresh property of SEC, again, the 3 requirements: flow, passing, and segregation resistance, and how we can control them. And the other type of high performance concrete, okay, that will be discussed in a moment. So next is NDT and the semi non-disrupt testing method, including ultrasound, GPR, cover meter, and among other methods. Okay, so you should know how this NDT method work and based on what properties. Okay, and what are the applications for this different type of NDT method. Okay. Maturity, you should know what is maturity. Basically time times temperature. Okay, so longer the time the concrete lasts, and higher the temperature the concrete cure, we have higher maturity. And how we can correlate the maturity with the strength of concrete. The next about mechanical waves. Okay, we have P wave based on compression, shear wave based on shear, and the relay wave or the surface wave. Okay. So again, as long as the materials, the medium has elastic response to, for example, compression, then compressive wave can propagate in that type of medium. If it has elastic response to shear, then shear wave can propagate in that type of medium. Okay. And then this is very important, how we can balance the resolution and the penetration. Okay. So the higher resolution for the mechanical wave, then we have better resolution. We can see more details, but the penetration will be shallow. Okay. We have less penetration because the energy will be dissipated faster when we increase the resolution, increase the frequency. Okay. And how we can balance these two, how we can choose the frequency based on application. For example, for concrete, we should choose the wavelength of the wave similar to the size of the largest coarse algae. Okay, so for coarse algae in concrete is around 1 inch or 2 inch. Okay, and other type of high performance concrete, we talk about fiber reinforced concrete, how the volume fraction, the length of the fiber, the diameter of the fiber, okay, affect fracture behavior of concrete. Okay. This is another important part. Cracking mode for fiber reinforced concrete, depending on the size, diameter, and the volume percentage of the fiber. Okay. And also how a fiber can increase the toughness and ductility of the concrete. Okay. Remember, we discussed how coarse fiber, which means the fiber has larger diameter and longer size, and short microfiber, which means the fiber has small diameter and the shorter length, and long microfiber, which means the fiber is long, but the diameter of the fiber is small. Okay, so how these different type of fiber affect the cracking mode. Okay. And then lightweight concrete, when we use lightweight aggregate, so we can reduce the density of concrete, and then mechanical performance will be affected. For example, the strength, the creep, modulus of elasticity, shrinkage, and even the failure mode will be different for lightweight concrete. And why that's the case? Okay. What is shotcrete? What are the typical applications for shotcrete? Polymer concrete, we discussed 3 types of polymer concrete. Okay, including polymer as the binding agent, latex modified concrete, and polymer impregnated concrete. So 3 different types. So what are the major difference between polymer concrete and traditional concrete, and why that's the case? All right. And then we discuss microstructure analysis. Okay, so you should know.
I'm sorry, what you said about the lightweight concrete?
The lightweight concrete, because we put lightweight aggregate in concrete, then for example, the modulus of elasticity will be lower. And why that's the case? Okay.
Oh, okay. I think I missed the modulus of elasticity.
Yeah, modulus of elasticity.
Okay.
Yeah. Oh, yeah. Okay. And then microstructure analysis. You should know how scanning electron microscope, mercury intrusion, parcel meter, X-ray diffraction. So how this machine works based on and what we can see using this method, okay, for concrete materials. Okay. And then finally, concrete retrofit techniques. So that's the last lecture. You should know when we select the materials, what are the consideration and what are the basic procedure to do the repair, including the surface treatment and so on. Okay. So again, this is open book. We'll prepare for the final exam. Okay, so make sure you go over all the materials and bring all the lectures to your final exam. So all the questions will come from these topics we just discussed. Okay, again, this is the time, May 11th, okay, to 15th. I will upload the final exam to La Lima as we did for the midterm. And yeah, so I think that's about it. Any questions for our final exam? Okay, okay. So if there's no questions, I will let you go. But before you go, please do the course review. Okay, so I'll just send you the link for the course evaluation. Okay, so that is required by the chair. So when you have time, please do so. Okay, so that will help us better prepare the class next time. Okay, so you can use the link and log in, but the survey is totally anonymous. Okay, so if there's no questions, I will see you guys next week for the final exam. And don't forget to give me the final term paper that day also. Okay, good luck, guys.
Okay.
Okay, take care.
Perfect.